SpaceX's Dragon, flying high above the Earth and approaching the International Space Station a little less than 100 meters away. And this is a live look as the capsule flies just over France, about 255 statute miles. Again, less than 100 meters away from its future home for the next month, the International Space Station. Good morning and happy Monday from Mission Control Houston. I'm NASA's Dan Hewitt, and welcome to our live coverage of the rendezvous and capture of SpaceX's 15th resupply mission to the International Space Station. As you can see, Dragon closing in now, and in not too long it'll be captured by the robotic arm on the space station by the crew on board. Back down here on the ground, the teams are monitoring and supporting the crew on board the station. The Orbit 1 team currently on console here in the International Space Station Flight Control Room. They are led by that man right there, Anthony Varia, the flight director this morning. And just next to him, you see Capcom Pooja Jezrani. She's going to be the voice you'll hear talking to the crew on board through these final stages of Dragon capture. And the crew on orbit right now, Expedition 56, a 6-man contingent of astronauts and cosmonauts from all over the globe. They are led by NASA astronaut Drew Feustel there in the front row on the left, and he's joined by 5 other crew members just over his shoulders. Russian cosmonaut Oleg Artemyev there on the left, and NASA astronaut Ricky Arnold, who's going to be the prime robotics operator for this morning's activities. And the other 3 crew members over on the right there in the front row, Alex Gerst from the European Space Agency. Just above him to the left is Sergei Prokopyev, a Russian cosmonaut, and all the way on the right there, Serena Anand Chancellor, the 3rd NASA astronaut currently on board. As mentioned, Ricky Arnold is going to be the prime for the robotic operations this morning. He's at the robotics workstation inside the station's cupola. As we get this another great view of Dragon, they're actually flying over Italy already, 255 statute miles over the Earth's surface. Both vehicles traveling a little over 17,000 miles per hour, circling the globe every 92 minutes. Dragon continuing to close in right now about 80 meters away. Ricky Arnold's going to be the prime for Dragon capture, so he's the one at the controls reaching out with the robotic arm to grab Dragon once it's only about 10 meters or 30 feet away. He's backed up today by Drew Feustel, the commander of Expedition 56. We'll hear Drew, his voice on the space-to-ground loops, talking to the team down here on the ground throughout the operation. And then Serena Anand Chancellor also in the cupola backing them up and providing support as needed.
Offsets or indications on the monitor.
Dragon's flown pretty quickly through all of its checkpoints over the last couple of hours this morning, actually running about 24 minutes ahead of schedule right now. Originally, it was planned to be captured at 6 a.m. Central Time here in Houston, 7 a.m. over on the East Coast. But we may actually be in an earlier capture window. There's some very specific lighting conditions. Basically, there needs to be enough light for the crew to reach out and grab onto the Dragon capsule. And so it has to be very carefully choreographed around the sunrises and sunsets that the station and the crew are seeing. But since they are about 24 minutes ahead of schedule, we might actually be in an earlier capture window, so we'll keep an eye out and follow along with the teams. For now, though, Dragon is about 70 meters, a little over 70 meters away from the station. The next major checkpoint for the vehicle is once it arrives at 30 meters. And Dragon, throughout the morning, since entering into what we call integrated operations with the station. So the flight controllers out at Hawthorne that have been overseeing the SpaceX Dragon from its launch back on Friday begin integrated operations, so talking very closely with the team here in Houston, where Dragon has to pass a series of checkpoints or gates, essentially just pausing at different moments, doing checkouts of all of its systems, its range finding, its LiDAR, its radars that are tracking the station as it does this final approach. And every time they hold, they check things out, and then they continue on. And so right now, the next major one's going to be once it hits 30 meters, it'll get there, and it will pause for a little bit. They'll check things out, and then once they get the go from the flight director here in Houston, they'll give the command to Dragon to continue approaching, and then it'll get to the capture point. Now, that capture point is only about 10 meters away, about 30 feet or so from the station itself, And once it arrives there, Ricky Arnold will get the go from the teams down here on the ground to reach out and actually grapple and take hold of that Dragon capsule using the station's Canadarm2 robotic arm, the 57.7 foot long robotic arm operated by the crew on board. Once Dragon's captured, they will actually hand over control of that arm to the folks down here on the ground, where a robotics officer here in Houston, working in conjunction with robotic specialists from the Canadian Space Agency, will then maneuver Dragon, taking control of the arm and pointing Dragon to the Earth-facing side of the station's Harmony module, also known as Node 2, where they will attach it and then it will get locked in place by a series of bolts. And on board Dragon, just a shade under 6,000 pounds of cargo flying up on this mission. Of that, a little over 3,700 inside the capsule itself and what's known as the pressurized section. So that's actually in the capsule that will get unloaded by the crew. And here's just a rough breakdown of all of the different cargo coming up in Dragon. Things like crew supplies, everything from food to clothes, and other day-to-day items for the crew. The bulk of the stuff coming up, science investigations, over 2,700 pounds, supporting dozens of different new research investigations on board the International Space Station. And other things like spacewalking equipment, vehicle hardware, spare parts, computer resources for the onboard network, and some hardware for the Russian cosmonauts as well. Then in the lower portion, also known as the trunk of Dragon, which is the unpressurized, there are two large payloads. One a science experiment known as EcoStress that's going to be studying the temperature and water usage of plants down here on Earth, and then a new latching end effector for the station's robotic arm. It's a spare for the latching end effectors on the robotic arm. There's one at either end of the Canadarm2, and you can kind of think of them as the hand of the robotic arm. They're used to grapple with different pieces of hardware, like SpaceX's Dragon, also used for things like spacewalks, and the arm itself was used to actually build the International Space Station piece by piece. So this will be a spare just in case they have any issues with the ones currently installed on the arm. Now though, Dragon continuing to close in a little under 60 meters away, still getting some pretty great views. Right now they're just flying over Egypt, about to make a pass over the Red Sea, and then they'll actually pass over Yemen and then the eastern coast of Somalia before heading out over the Arabian Sea. So we'll continue to follow along. They are again running about 24 minutes or so ahead of schedule, so we'll see when Dragon gets to this 30-meter point, and then if they get into an early capture window or not. Again, the original capture time was 6 a.m. Central, 7 a.m. Eastern, but if Dragon continues to move quickly and smoothly through all these different checks, no issues being tracked so far today with the vehicle, we may actually get a chance to capture this vehicle early.
Station on 1 for Dragon coming up on 50 meters. We see 51.4 on prize, secondary 50.5. On camera 9, we see the light is within the corridor. The vehicle outline is approximate to the vehicle size. The circle is offset from the light. It's not really offset from the light, and the circle is offset from the center of the corridor. Quarter vehicle forward and slightly starboard. In the monitor 1, camera 3, we see the outline and circle offset to the starboard side and forward, and we see the vehicle offset to the port side and forward.
And we copy all. Nominal report. And we're tracking 25 minutes ahead of the timeline.
Houston, how does that set us up for light-dark effects for grapple?
I'm checking.
I guess the question is, are you guys going to have us hold till we come in the daylight to make sure that we grapple in the daylight?
Checking. And Station Houston on 1. So we're not going to have you hold for daylight, but we are currently set up to be at the end of the current window. So we may need to hold to go to the next window so we're not in full sunlight. By that I mean blooming the cameras.
Okay, we'll stand by for your call on the go. Taking your last, Houston.
And what I was saying is that we may wait for the next window so that we're not blooming the cameras with sunlight. And we'll keep you posted, of course.
Okay, will that put us back on the nominal timeline then?
And that'll put us pretty close to the nominal timeline if we do that.
Okay, copy. We'll stand by for your words.
The crew on board getting a quick update from the team here in Houston. Again, Dragon moving very quickly through all of the design checkpoints on the timeline today, currently about 25 minutes ahead of schedule. But again, they have to plan the capture around the rising and setting of the sun, basically making sure that they have good conditions for the cameras themselves to get a clear view of the vehicle. You heard Capcom Pujic, as Ronnie referring to, as blooming the cameras. Basically, you don't want the cameras to be in a position where the sunlight is giving an obscured or distorted view of the vehicle itself. They can capture the vehicle during a night pass, which if we manage to hit the current capture window, the capture would actually occur at nighttime for the vehicle. But again, we'll continue to follow along. Dragon still closing in. Again, that next major milestone is going to be once it hits the 30-meter point. And right now, just about 5 meters away from there, so we should be hearing that in just a little while. Meanwhile, the vehicle continuing to fly about 251 statute miles over the Earth's surface. They are just beginning to pass over Somalia.
Houston Station on 1, we see visiting vehicle mode, hold, pry, 29.5, secondary 30.
We copy.
And so with that, the Dragon spacecraft holding at 30 meters away from the International Space Station.
Ensure that we're at 30-meter hold. We are performing our assessments on the ground, and we'll let you know shortly when you go to proceed with step 4 and 1.102.
Do that.
And so now the teams will run a check on Dragon systems. Again, working with the teams out in Hawthorne, California at SpaceX's Mission Control Center. Once everything is confirmed to be good to go, they can give the crew the go, and then Dragon will depart this 30-meter hold point. You can actually see the capture point illuminated perfectly by the sun right there. The rest of the vehicle shrouded in shadow, but that capture point on the vehicle itself, so that small flux capacitor-like looking device there on the Dragon's actually where the robotic arm is going to reach out and attach to get a firm grip on the Dragon spacecraft. And this actually a view right down the business end of the Canadarm2 robotic arm. And we'll see this piece close in on the Dragon spacecraft once they get the go to capture when it's about 20 meters closer.
Station Houston on 1 for Dragon. Please perform step 4 in 1.102. Your go for maneuver to high hover.
Copy that. Work on step 4 of 1.102. Takes us to 1.110, step 3.
Good readback.
And again, right now, Dragon holding at 30 meters. Once they give the go, the crew can actually command the vehicle to depart 30 meters. The crew has a command console right next to their robotic workstation where they can actively send commands to the vehicle, even empowered to make the vehicle abort its approach and fly away if necessary. But everything going very smoothly and ahead of schedule. We're about 25 minutes ahead or so, still on the planned timeline for this morning. And then once they get the go to depart this 30-meter point, it'll fly in for about 15 minutes or so, arriving eventually at the capture point, which is just about 10 meters or about 30 feet away from the station. Then it'll be back up to the crew, and Ricky Arnold, the flight engineer with Expedition 56, will be commanding the robotic arm to reach out and grapple with the Dragon spacecraft. And so that'll be coming up real shortly. But for now, still holding at 30 meters. We should be getting the go to depart momentarily. And as you can see from this view, the robotic arm itself is now in motion. It's going to position into what's known as high hover Basically just its positioning right before it's ready to drive straight in and capture the vehicle.
Motion for high hover.
We copy.
Meanwhile, Dragon and Station continue to fly over the Indian Ocean. They're about halfway between Madagascar and Sri Lanka right now. And as Dragon continues to hold at that 30-meter point, the station's robotic arm getting into position. The teams here in Mission Control Houston going through their normal procedures. They'll typically talk through as a refresher just what abort scenarios and things like that could look like. Make sure everybody is on board and ready to go before they give the go for Dragon to depart that 30-meter point.
So we see the armor position hold.
We copy.
The station's robotic arm now in its ready and waiting position. Dragon still just 30 meters away. And once the teams finish their final steps here on the ground, they'll give the go. And Dragon will begin approaching once more, slowly but surely, towards the International Space Station. It'll get to a point about 10 meters away.
We see that you're in position, and let us know when you're ready for the approach to the capture point.
Okay, stand by. We are going to complete the snapshot and verify the position.
Copy.
And so just a few more steps and then the crew will be ready, and then Dragon will begin closing in once more on the station from this 30-meter point. It'll get to what's known as the capture point, which is a place about 10 meters away from the station, and it'll once again stop and hover. And then the crew, namely Ricky Arnold, a NASA astronaut on board, will reach out with the robotic arm and grapple Dragon, and then Dragon will be captured.
Per procedure 1.110, the brakes are on and the SSRMS is in the high hover position.
Copy, high hover.
Houston station on 1 for Dragon. The crew is ready for Dragon approach to capture point.
And we copy that the crew is ready for Dragon approach to the capture point.
Houston station on 1 for Dragon. We're standing by in the 1.102, step 5.
And we copy, and 1 go back on 1.110. We'd like you to confirm step 3.2 for the camera views.
Houston, we can confirm the overlays and indications. It was our impression that the camera views were per our discretion, so if that's the case, we're happy. Otherwise, we can set them for the indications per pan and tilt.
And we're checking. And we're good with your discretion.
And a quick loss of signal. We'll get the video back momentarily. The station and Dragon actually going to be crossing the terminator line, the line between night and day on the Earth's surface, pretty soon. So once we get that back, we'll get some pretty spectacular views. Again, Dragon still holding at 30 meters, but the team's out here ready to confirm that it's about to depart.
Dragon is ready to proceed to the capture point. Expect approach to resume shortly.
Station copies.
So the team's out at Hawthorne. The SpaceX mission control will command Dragon to depart this 30-meter point. Here we're getting a look in the room at the SpaceX flight controllers. We've been working throughout this morning with the team here in Mission Control Houston. And in just a moment, we'll get the call that Dragon has departed 30 meters and is once again closing in on the space station.
In Houston, we see VV mode on approach.
Copy and concur. Station Houston on 1, Dragon has begun approach from 30 meters. Monitor per step 5 and 1.102.
Station cover.
And so Dragon in motion once again, departing the 30-meter point, now on its way to its final hold point at the capture point, at which point, once it's confirmed to be in a good state, the crew on board will be able to reach out with the robotic arm, grapple the vehicle, maybe one step closer to getting Dragon attached, the hatch opened, and then a month-long odyssey of science and research and a lot of cargo loading and unloading for the crew on board. And as you can see, the Earth's surface beginning to darken as they're about to cross that terminator line. The station pretty soon going to be entering into an orbital nighttime.
Houston Station on 1 for Dragon. We see Pry 27, secondary 27 in camera 3. We see the light is in the corridor. The circle, the vehicle outline matches the vehicle size. The strobe and the circle are slightly forward, about a half a vehicle width length. In camera monitor 3, camera 9. We see the light in the corridor, the outline similar to the vehicle size. The strobe and circle are both forward and slightly starboard of the center of the corridor.
We copy all. Nominal report.
Dragon continuing to close in on the International Space Station. As you can see, it is an orbital nighttime now. Right now, they're a little under 21 meters away from the station.
Station Houston on 1 for capture window.
Go ahead, Houston.
So it looks like we're going to be able to make the first window, but it will be a night capture. If you want to wait about 15 minutes, we could do a day capture, and we're happy either way, whatever you prefer.
We're talking about it. Can we make that choice when we get down to 11?
Absolutely. We just wanted to give you these words ahead of time.
Copy that. And we see Pry 20, secondary of 20. Looks like both camera 3 and camera 9 are tracking the same outline, strobe, circle. All have good alignment. The circle is forward and starboard in both views.
And copy all nominal status.
Houston Station on 1 for Dragon. We see us coming inside 15 meters, and the question is, what we see is a pretty grainy image on the center monitor for the end effector camera, and do we think that's going to get better with this lighting, or is it going to stay fuzzy and grainy? It's difficult for us to see the pin alignment at this point.
Checking. So So we're hearing that we expect it to stay the same overnight, but will get better with sunlight.
Houston, as we approach the 11-meter hold point, talking about it here with the way the image looks, we don't have high confidence in what we can see. It's probably aligned, but I think we'd feel more comfortable if we had a little bit better lighting on the target, and so our preference would be to just wait it out if we can until we get some lighting on the target.
And we completely understand, and with that, it'll be no earlier than 27 minutes from now.
And so right now, Dragon almost at that capture point. It's just a little under 11 meters away. It'll stop once it gets to 10, but as you just heard, the crew wanting a little bit better lighting condition for them to do this operation, so they'll actually hold off until the next capture window opens up, which will put us back on the nominal or the planned timeline. The earliest go for capture, so the start of that window, will be 5:44 a.m. Central Time, 6:44 a.m. Eastern. So Dragon shortly will get to this capture point. They'll do the final go-no-go for capture, and then we'll wait for the opening of that window, again at 5:44 a.m. Central, so about 26 minutes from now. And then they'll give the crew the go to reach out and grapple with the vehicle.
Station Houston on 1, please confirm capture point hold for step 6 in 1.102.
Houston, we can confirm that we see CP hold with a range of 11 on prime secondary.
We copy?
Verify the CCP lighting config as well, that hold execute is flashing.
And we copy.
Houston Station on 1, we're going to take this opportunity to turn off the strobe light.
Copy, no issues.
And so we're in a bit of a lull here as the SpaceX Dragon will hang out here at the capture point until the lighting conditions get a little bit better. And again, we're expecting the earliest go for the crew to move into capture, and it will come at 5:44 a.m. Central Time, 6:44 a.m. Eastern. So we do have a little bit of time until it's time for the crew to reach out and capture Dragon. In the meantime, if you're watching and you have any questions, you can hop on Twitter and use the hashtag AskNASA. Send them in, and we'll do our best to get through as many as possible during this broadcast. We will go ahead and start off with one that we got in from Gaurav Singh, who wanted to know is Simon designed for spacewalks. And Simon's actually one of the experiments, over 2,000 pounds of science hardware packed away inside. But Simon, also known as the Mobile Companion, is a small free-floating satellite with artificial intelligence built in. That's going to be testing this out. It's a European Space Agency investigation, so European astronaut Alexander Gerst is going to be interacting with it. It's not designed for spacewalks, only going to stay inside of the station, but it's going to be using artificial intelligence basically as a personal assistant, a helper, to assist the crew in all of their day-to-day activities. And it's being investigated as something that could potentially be used to reduce the workload and the stress level on these crew members while they're in this isolated environment. Something that useful on board the International Space Station, not necessarily a very urgent need, as help is always a very quick radio call back down to the ground away. But on future long-duration missions, as we go farther and farther away from Earth, help is much farther away. In fact, crew members on a mission to Mars could experience communication delays up to 40 minutes at a time, just from the round trip between sending a voice call back down to Earth and then getting the response back. So scientists and other mission planners looking at exploring the use of artificial intelligence to hopefully help crew members on space flights, giving them as much of the knowledge base of humanity with them as they travel in spaceships far away from Earth. Our next question comes from Rylan Barton, who wanted to know how come the SpaceX Dragon cannot dock on its own. And it's a feature of the type of docking mechanism that Dragon uses. So with spacecraft traveling to the station, there's two very distinct means of attaching. One is docking and one is berthing. Now with docking, which is what we see the Russian Soyuz and the Progress do, there's an active docking mechanism both on the spacecraft itself and on the station side. Those docking mechanisms come with a bunch of different hardware requirements, but one of the biggest reasons why Dragon doesn't use that is the berthing mechanisms are actually much larger. You can fit a lot more through the common berthing mechanism ports on the station than you can through a docking port. And for cargo, that's a very big plus. You can fit much larger payloads through the hatch. However, the berthing mechanisms are passive, so they don't have an active system on there, so Dragon can't just fly up and attach right in. It has to actually be installed. It's the same type of mechanism that connects each of the modules themselves, but again, it's much larger, and that's why Dragon uses that common berthing mechanism as opposed to a docking system. And then our next one, Daniela wanted to know what happens to Dragon when it's unloaded. Does it stay at station like a Soyuz? It stays at the station until its mission is over and it's reloaded full of cargo, and then it comes back down to Earth. So this Dragon will stay at the station for just about a month. It'll come home the first week of August after it's packed full of several thousand pounds of equipment. And then the top portion of the vehicle, which cuts off just above the solar arrays there, actually can re-enter through the Earth's atmosphere using a heat shield and splash down in the Pacific Ocean and return science samples. Dragon's currently the only cargo vehicle capable of returning hardware and research back down to planet Earth. So Dragon will stay at station for about a month. The crew will unload it, it'll reload it, it'll get packed up, and then come home. And then one more from Hari. He wanted to know, how much time does it take to open the hatch after docking to the space station? It varies. It can take anywhere from a couple of hours, as the crew has to do a couple of activities just to get the hatchway between Dragon and the station outfitted. There's some ventilation and power and other systems that they have to put in place before they can open up the hatch. Some crews will get it opened up within a matter of hours. The timeline today actually calls for them to wait until tomorrow morning to open it, but crews that get ahead of schedule will sometimes get it open the exact same day. Once they get the hatch open, though, there's a lot of research that has to come off, so it all depends on how quickly through their day they can get it open. But if you have any questions, again, hop over on Twitter, use the hashtag AskNASA. We still have about 15 minutes or so until that capture window opens up, so we'll go ahead and try to get through a few more questions as we can. All right, we're still about 12 minutes away from the open of the capture window. We should be seeing a sunrise right about 11 minutes from now, and then just about a minute after or so, the crew will get to go to capture. They'll have some better lighting conditions. They'll be able to reach out with this robotic arm and capture the Dragon spacecraft. In the meantime, we got some more Ask NASA questions. Again, if you have a question, go over to Twitter, use the hashtag AskNASA, shoot us a question, and we'll do our best to answer. Our first one now comes from Kai, who wants to know, why is the Dragon spacecraft at the station for over a month? And a lot of that actually comes down to a lot of the science experiments on board. Some of the research that flies up in Dragon has basically a timeline that it needs to achieve. It needs to be exposed to microgravity for a certain amount of time before it comes home, just to make sure the experiment's actually executed. A lot of your biological studies, your rodent research studies, things like that Dragon delivers, and then brings back down to the ground have to be in that microgravity environment for a certain amount of time just to make sure that it's been exposed, and then it comes home. So that's why it'll be at the station for about a month. Our next one comes from Steve and wanted to know what's the final approach speed of Dragon as it moves from 30-meter hold point to the final berthing position. It's actually very slow. Now Dragon and the station are moving at over 17,000 miles an hour, but the relative speed between the two of them during that final approach is almost glacial. It's typically less than 1/10 of a meter per second. So that's why once it left that 30-meter point, it was about 10 to 15 minutes before it just moved 20 meters closer. So it does move very slowly, very deliberately, and that's just how most spacecraft, when they're operating around the International Space Station, move. The Soyuz moves at a relatively faster 1/10 of a meter per second, but yeah, SpaceX, but very slow, very deliberate, just making sure that it's safely approaching before it gets to that capture point. Zeke wants to know what are the emergency abort procedures if you needed to kick away the Dragon capsule. Well, if the crew ever got an indication that something was awry with the vehicle, they have a console on board the space station, actually right next to their robotic workstation where they're situated in the station's cupola, where they can send commands to the vehicle. So this is actually a camera view on the robotic workstation where the crew is looking at the Dragon and monitoring, and pretty soon they'll be using the robotic arm to reach out and capture it. But they have a small command panel where they can send commands to the vehicle, and they have an abort button on that command panel. So if they needed to get Dragon away from the station for any reason, it's literally the press of a button, and they can send that command to the vehicle. Our next one comes from Homem, who wanted to know how did NASA used to supply the station before the Dragon? Well, before Dragon and our other commercial resupply vehicle, Cygnus, the station was resupplied by the space shuttle, which would bring up very large loads of supplies to the International Space Station, and also by the international fleet of resupply vehicles, many of which are still bringing supplies and science and cargo to the International Space Station. There's the Russian Progress vehicle and the Japanese HTV vehicle. There was also the European ATV, which flew several flights to the station before ultimately retiring. Next one from Sean wanted to know what supplies does SpaceX's Dragon carry up to the station? How long does it take to unload? Well, it takes a couple of weeks. They'll have everything mostly unloaded within the first 2 weeks, and that'll put them about halfway through their mission, and then they begin the process of loading things back on. And then the supplies themselves run the gamut of everything from crew supplies, so things like food, sometimes water, clothing, just day-to-day items for the crew. The bulk of the lion's share of the cargo that comes up is science, so that is experiment hardware, whole experiments themselves, experiment support hardware, so things like just test tubes and syringes and things you need to do these human research experiments on board the station. Also spacewalking gear, vehicle spares, so spares from everything from the toilet to communication systems to computers, all of that on board. And then Dragon also capable of bringing up unpressurized cargo, so stuff that's outside the capsule in the trunk portion, and it can bring up large external experiments. It has one on this flight which is called EcoStress, which is going to be studying plant water use back down here on Earth. Also has a latching end effector, so one of the hands for the station's robotic arm, also in the trunk. Our next question comes from Graham, who wants to know what sort of items will Dragon bring back to Earth on its return journey? The stuff coming back down kind of mirrors the stuff that came up, so a lot of the research that Dragon brings up, it will also bring down at the end of its mission. It'll also bring down research samples from a number of different experiments that get loaded on. As again, Dragon, one of the main modes of actually returning anything from the station right now. It's the only cargo vehicle capable of bringing stuff back from the station. This Dragon's actually also going to bring one of the older degraded latching end effectors from that station robotic arm back down to Earth for it to get actually repaired by the Canadian Space Agency and eventually flown in the future as another spare. Next question comes from Telecaster, wanted to know, how's the robotic arm operated? Well, for the capture operation, it's operated by the crew. Again, they have a robotics workstation, so a console, and they actually have a small joystick-looking device that they can use to send commands to the arm itself that they will then reach out and capture. It can also be operated by people down here on the ground, and that'll be what happens after the vehicle's been captured. They'll hand over control to the team on the ground, because actually maneuvering it to get attached or berthed to the station is a much longer, drawn-out process. So the crew goes back to work and they let the teams down here on the ground operate that. But it can actually be commanded from here in Mission Control Houston or a telescience center up in Canada, where they can actively send commands to the arm from planet Earth to actually move it. And they'll be doing that a little bit later this morning after Dragon is captured. And then our next question comes from Kristen, who wanted to know, is this the first time a reused capsule has been captured by the station other than shuttle missions? It's not. Actually, the previous SpaceX flight was a reused capsule. So this SpaceX capsule for the 15th resupply mission actually flew back in July of 2016 on SpaceX's 9th resupply mission. It delivered the International Docking Adapter number 2, which is currently attached to the station. The previous SpaceX flight, which was their 14th resupply, used the capsule from the 8th resupply mission. So this is not the first time that SpaceX has reused a capsule, and it definitely won't be the last. Their current plan is to reuse these capsules throughout the rest of their contract for commercial resupply flights to the station until they start their second generation, also known as Commercial Resupply Services 2, where they'll be switching to an upgraded Dragon. Again, if you got a question, head over to Twitter, use the hashtag AskNASA, and we'll do our best to get to it. But for now, we're continuing to hold. We should be getting the open of the capture window in about 4 minutes or so. Then we'll hear the chatter pick up again between the crew and the people down here on the ground here in Mission Control. The station and Dragon, meanwhile, still in an orbital nighttime, flying at an altitude of about 253 statute miles. Are actually just coming up on Baja California and about to make a pass over the very northwestern part of Mexico, then out over New Mexico, and then the central part of the United States, swinging up over Canada and into an orbital daytime.
Station Houston on 1 for Dragon. Are you ready for capture for step 6 in 1.102?
We are close.
Copy, standing by.
In Houston, we are ready for step 6.
And we copy all stations. So with that, when you're happy with the lighting, you will go for the capture sequence. Please perform step 4 in 1.110, Dragon capture, and begin monitoring the backaway cue card.
Okay, we will proceed to step 4 in 1.110 and switch over to the backaway cue card.
Good read.
Houston, we're proceeding with step 4.2 for thruster inhibits.
Copy.
And this is Mission Control Houston, the crew stepping through their procedures now. Pretty soon we'll start to see this robotic arm close in on that capture point right there on the Dragon capsule. Expedition 56 Flight Engineer Ricky Arnold's the prime at the controls this morning, being backed up by the current Expedition Commander Drew Feustel.
Station on 1. We are complete with 4.2. We're beginning to line up with the arm, and then we'll start in, and you should see free drift by 1.5.
Copy all.
And we have confirmation the robotic arm in motion, the latching end effector approaching Dragon. Four meters and closing.
Houston, visiting vehicle free drift.
Copy.
The Canadarm2 just 1 meter away. Initial contact. And we have capture confirmation. The capture coming at 5:54 a.m. Central Time 6:54 a.m. Eastern Time, while the station in Dragon flew 256 statute miles over Quebec. So the Canadarm2 capturing Dragon while the station in Dragon flew over Canada. Very appropriate, as yesterday was Canada Day, so very fitting and a very flawless capture for the station's robotic arm. Dragon now within the grasp of Canadarm2.
Houston, station on 1, we see close, capture, rigid eyes, we're watching the tension continue up, and position 23.4.
Copy all.
In Houston, per 1.110, we see all the conditions for close capture.
Copy and concur.
And so with Dragon captured, the crew now safing the robotic arm.
Station capture complete. For post-capture reconfiguration, looking forward to some really exciting weeks ahead as we unload the science and get started on some great experiments.
And copy and concur. Great work today, guys. You guys made it look easy. This is the 30th visiting vehicle capture.
It's hard to believe as we were watching Cygnus climb up the R-bar, just thinking about, Dragon climbing up the R-bar, how far we've come. It's quite an accomplishment.
Agree, and it was fitting that it happened over Canada.
That's why Drew wanted to wait for the lighting.
Now it all makes sense.
And thanks to everybody for the support down there. Great teamwork and great effort. And as Ricky said, we're looking forward to opening the hatch, and we got some great science ahead of us.
We couldn't agree more.
All right, with Dragon captured, controls now going to get handed over down here to Houston, where robotics flight controller is going to spend the next hour or so maneuvering Dragon into its berthing position, where it's going to be attached to the Earth-facing side of the Harmony module. But we are going to break away for a little while that occurs, and then we'll come back on once we're just about ready to get Dragon fully attached. So we'll be back at 8 a.m. Central, 9 a.m. Eastern Time here on NASA TV to continue our coverage and get Dragon installed to the International Space Station. Once we come back, we'll continue to answer some social media questions. So for now, if you have any questions, head on over to Twitter. Use the hashtag AskNASA. Send them in, and we'll try to get them when we come back on our next broadcast. For now, though, Dragon captured successfully. Capture at 5:54 a.m. Central, 6:54 a.m. Eastern, while the station in Dragon flew just over Quebec province in Canada. So we'll be back in just a little while, so stay tuned for continuing coverage of Dragon's 15th resupply mission to the International Space Station. For now, though, we will go ahead and sign off. This is Mission Control Houston.